Alrighty. Hi everyone, thank you so much for joining me. I appreciate you guys joining me on like your Thanksgiving break especially. I know last week I was in here, we canceled class. That's because I was at my FBLA Fall Leadership Conference, so that was my last Fall Leadership Conference ever for FBLA. So that is definitely kind of sad, but it was a good event. So yeah, that's why there was no class last week, but I appreciate you guys being like flexible and everything. So if you're joining us, thank you very, very much. We'll do some very interesting stuff today. I think today will be like probably a pretty foundational lesson. So hopefully it'll be like worth your while. Hopefully you'll be happy to be here. But I guess like before we get started, because it is Thanksgiving break, let's go ahead and talk about like what your favorite Thanksgiving tradition is. So Hithart says break period. Honestly, yeah, that's true. I like that even though we only celebrate for a day, we get the entire week off. So that's like super nice. Cypernete says sleep. Yeah, that's true. This is like a good time to catch up on sleep and also like maybe get your sleep reserves ready for midterms week if you have a lot of hard midterms. I think that's fair. Audie says play. Yeah, that's good. Like going outside and playing and not just staying inside and like watching TV all day. I like that she said that, Audie. With family. Yeah, that's good. That's really good. Amari says turkey. Oh wait, I realized I'm not writing any of these down. Oops. Break, sleep, play. Turkey. I don't think I missed anything yet. Okay, perfect. Yeah, turkey is awesome if cooked well. Okay, amazing. Yeah, I'd say my favorite tradition is cooking. I love to cook, so this is some like this is obviously like one of the greatest holidays in my opinion because I get to like make a lot of food. But yeah, groceries are unfortunately like expensive this year, so that's one downside. But yeah. Oshrid says, all I do is sit and watch TV and prepare for midterms. So I'll put TV on here, but I'll make it super small because TV is meh. But you can do study. Study is also kind of like meh. You should use this break to relax. Um, yeah, I would say like don't study. Maybe like study for the last 2 days of break because like you have 2 weeks until your midterms, so like that's kind of like stressful. But don't spend your entire break studying, and also like don't spend your entire break watching TV. Like go on a hike. Very nice weather for a hike. Pick up a hobby. I don't know. Maybe like you like to play like pickleball or basketball or like a sport. Maybe you're like creative. Like maybe draw. Or like paint or crochet or something. Or if you're like me, cook. I like to cook. Bishop says relax. Amazing. Yeah, that's good. Yes, definitely relax. But like relax productively. Like don't binge TV because that's not relaxing. Oh, Winnie asked what happened in the last 2 weeks. Well, Winnie, we are so happy that you are here today after 2 weeks. Um, let's see. What did happen in the last 2 weeks? Okay, so there's no algebra class last Monday. Then we had geometry class on Wednesday, and then we have this class today, and we have no class on Wednesday. Or sorry, no algebra class on Wednesday. So we'll have this. This is our second to last geometry class, and then we'll have our last classes for geometry and advanced algebra next Monday and Wednesday. So after that, we are going to be done for the semester, especially just because everyone has like midterms and stuff, and it's kind of hard to attend classes on top of that. So just for everyone's sake, we'll go ahead and end classes for this semester, but classes will start back again next semester. So don't worry, like this is not the last time you'll see me, I promise. But yeah. Okay, cool, cool, cool. Cool. What other things are there? I think my sister right now is doing like a lot of painting projects, so I would say like maybe painting is a good one. She's making this like very big canvas for my aunt as a gift. So I think that's pretty cool. Let's see. What other th traditions are there? I feel like there's not a lot. It's too cold to go outside. Maybe like Black Friday shopping. Maybe that's something you like. That could be a good one. But yeah, I feel like this is all I can think of. Aside from eating. Oh yeah, let's definitely put eating. This is like a good tradition. That's one of my favorites too. Um, it's like okay, that's actually true. It's not like that cold, but I also am not like it's not like I'm gonna get up and like go out like 7 in the morning to like go on a hike or something. And then like in the afternoons like burning hot. So oh yeah, it's also like everyone is ill. That's also true. So it's like hard to find people to hang out with. But yeah. Unfortunately that sucks. I hope you get better, Sai, though. I hope you feel better. Oshrid says in Canada, it's like a blizzard with negative 12 degrees Celsius. Okay, that is just crazy. Wow. Here, okay, because we're in the south and because of like I think it's La Nina, it's actually gonna be warmer for us than normal, so it's not like super duper cold. But yeah. Okay, awesome. So, on that exciting note of talking, let's go ahead and jump into today's content. So, today, because you guys have joined me on, I'm sure, your break, I want to give you guys like a very awesome lesson. So, today we're going to be talking about power of a point. As weird as that sounds, a point is very powerful if it's in a specific shape, and that specific shape happens to be a circle. So, how many of you guys have like even heard of power of a point? I'm just curious. Okay, Oshred has. Awesome. It's okay if you have it. I just want to see how much is this, how much of today is going to be new stuff. So that way I can pace myself and make sure everyone has enough time to understand everything. Okay, I think it's just Oshred. It's totally okay. I can't remember if this is taught in middle school or not. It might not be. But yeah, I think it's definitely taught in high school, but I can't remember if it's taught in middle school. Okay, so this is gonna be one of those classes where because like proving the theorems takes more time, and I want to show you guys how to apply it instead, we're not gonna spend time going through the proofs, but you'll be able to see it. We'll give like some motivation for like where this comes from and like why the ideas we're talking about like make sense. But we're not going to rigorously prove it. It's not impossible to do. It's like a very approachable proof, but just because of like how long it takes, that won't be our priority for today. Okay. Cool, cool, cool. Oh, so it doesn't seem like anyone's like super familiar with it. You guys have only heard about it. Okay, interesting. I feel like some of these theorems you guys like probably know, you just have never put a name to it. But yeah, we talked about some circle theorems like 2 weeks ago, so that's like a good part of it. But power of a point is a little more interesting. Okay, so like what even is power of a point? Basically, it's this like very cool theorem with circles that kind of relates the lengths of the line segments. That like okay, actually it might be easier to draw this than like talk about it. So I'm not going to use my circle drawing tool. Oh, wait, actually that's a really nice free-handed circle. Okay, so what power of a point does is it kind of talks about the wow, Oshrid is like hating, and Hithart is like, yes, that's a tough circle. Okay, Malvin asks for orange. Yeah, let's do orange since I already did purple. Okay, so basically the PowerPoint says is like, if I have some line segments that kind of like go through the circle, okay, that's like a bad line. Okay, if I have like a line segment that like passes through a circle, um, and then like maybe I have some other line and these lines like intersect. Power of a point will tell me something like, oh, it looks like an orange. Wow. Power of a point will tell me something about like the lengths of the lines. So yeah, like it's a very interesting theorem. There's definitely like a lot of use cases, and I think it makes the most sense if we kind of just go ahead and like jump straight in. Okay. So power of a point is casework, meaning there's three different cases for us to consider. The first case is going to be like, let's say the point P, where the two lines intersect, is going to be outside the circle. So this is an example of that first case. And actually, maybe I won't draw a tangent. Maybe I'll draw like a secant. So let's say this is like my point P. This is my powerful point, okay? And so this is case one, outside the circle. Okay. Wow. I just love how Hitarth is just like hyping me up about like all my shapes. I so appreciate that. Okay. Anyways, so these two lines intersect. We'll say like this is line L, this is line M. Wait, I don't actually like that M. I'll just do like a normal M. Okay, that's line M. Um, Okay, so if these two lines like from point P intersect like at in this circle, and let's say like maybe it intersect like line L intersects at A and B, and line M intersects at C and D, then power of a point says that PA times PB is equal to PC times PD. Okay? And so what this is basically saying is like this length times this entire length is equal to this length times this entire length. Okay? There's like a nice proof for why this is. Like I said before, though, we won't get into it just because it takes a little bit of time and I want to show you guys some interesting problems instead. So yeah. Okay. Cool. Is everyone okay with this? Does this, I know we didn't talk about like why this is true, but does this kind of make sense? Okay, Manit knows this. Good. Yeah, I think this is like definitely known, but maybe you guys don't know the name because you've definitely like worked with some of these things before. Okay, this kind of makes sense. Well, it'll definitely make more sense the more problems we do. But right now I'm just kind of introducing this idea. Okay, so case oh, whoopsies. That's not what I wanted to do at all. Okay, case one has like a special subcase. We'll say that's like case 1.1a. Okay. Yeah. So this is like kind of the diagram I had drawn before. So case 1a. Um, it's like still outside the circle, so like it's still outside the circle, but instead it's like a tangent line. So remember before my circle, okay, remember before that my circle, or sorry, my line M, I remember how I had changed it. Okay, now I'm gonna change it back. So I'm gonna like delete all of this actually. Oh no, not the circle. I don't want to delete the circle. Wait, is it even possible? Okay, yeah, it is possible. I just have to be like super careful. Okay, so instead, I'm gonna draw my line to look a little something like this. And remember the definition of a tangent line, right? It's something that intersects the circle at exactly one point. So I'm gonna say this is like C, okay? And this is my line M. All right, so when one of the lines is tangent, then my relationship is now gonna be PA times oopsies, times PB is equal to PC squared. Okay, and like intuitively, this kind of makes sense. Because if you think about it, like before in this equation, we had PC times PD. But now that there is no PD, you can kind of think of it as like, oh, there's only one point where they intersect. And so it's going to be the same length for both of them. So these formulas are very, very similar. We just don't have 2 points here. And so like PC is the entire length that we can measure. So that's kind of like all we care about. Okay. Is that clear? Like, does this make sense? Like how this is a subcase of this, like how this comes from here? If that's like confusing or no, okay. So Oshrit says no, Amari says no, Mani says yes. Okay, so let's kind of go through that again. Um, yes. Okay, so what I'm kind of arguing here is like with a tangent, I only have one intersection point. Okay. And so with this intersection point, notice how over here I have two different ones. So I have C and D. And the general idea is with PowerPoint, you're taking the length of the first intersection and multiplying it by the entire length between P and the farther intersection. Okay. So there's two different intersections, meaning you're multiplying two different like lengths. You're taking that first length and then the total length. Okay. So in this case, because there's only one intersection, the first length, the closer length, is actually going to be the exact same as that farther length, PD. And you can kind of see this as like maybe we're moving D closer and closer and closer and closer to the circle until it's exactly on top of C. And when it's exactly on top of C, like obviously those distances are the same thing. And when it's exactly on top of C, that actually means you have a tangent point, right? Because a tangent point only intersects at one point. If it didn't intersect at one point, it would be a secant. Okay? So I think maybe the best way to see this is like, let's say I had instead drawn my tangent line. So it starts from C, it goes through D, and or it goes through C, and instead it maybe like intersects here. Okay? And so I'm basically like moving D up and up and up, and like maybe I'll eventually get here, and then finally I get to like C, right? And so now it's the same length, PC, PD, it's all the same thing if it's right on top. And so we'll say like PD is actually PC, and that's where the PC squared comes from. Okay, so this is like basically a more specific case where like maybe you don't have two intersections, but instead just one. So that's kind of where like the method for this comes from, or like the idea from this comes from. Okay. All right. Let's see. Many asked, like, why do you need this? What is the purpose of this? I would say power point is probably the most important theorem when it comes to dealing with circle problems, just because of like how versatile it is. It's very cool that you can like establish a relationship just based on the location of one point. So it's a pretty powerful theorem. There's lots of different problems you can solve with it, and we'll look at quite a few. But yeah, you'll see that it's like pretty useful. Okay. Where could you use this? Both Otmani and Oshrit ask. Mm, You can use this in any problem with like tangent, secants, and chords where you're given some of the lengths of those values. Typically, like you won't have an entire problem where like the solution is just power of a point, but like power of a point will be really important in maybe finding the lengths of something. So like power of a point is going to be that good intermediate step. Yes, we'll definitely go through some sample questions. I just want to finish up the theorem first, and then we'll get to those sample questions. Okay, so this is like case one and like case 1A. So then let's go into case two. So case two is gonna be, if we had just talked about like outside the circle, the next obvious leap of mind is like, let's look inside the circle, right? So case two is gonna be inside the circle. Um, Power of a point is always with two lines. There's never three lines. It's always two lines intersecting, and like that intersection is your powerful point, okay? You're gonna be finding some crazy relationship with that powerful point. Okay, let's see. Did I copy? Ah, yes, I did. Okay. So I'm gonna make this like a little bit smaller. Oh, wait, I actually don't want to do that at all. Okay. There's really like no relationship with through lines, I'd say. Like maybe you can find some hidden PowerPoint, but off the top of my head, I can't think of anything with three lines, like a direct relationship with three lines. So case two is inside the circle. Honestly, at this point, I probably should have redrawn the circle, just because now I have to erase all these lines. But it's okay, it's no big deal. Okay. Oh, this is always the hard part, getting rid of these dots. Okay, so now with inside, I would honestly say like inside is probably easier because we're dealing with chords. And so remember, chords are basically anything, like any line on the circle. Oh, why are my lines super like thin? Okay, that's like really weird. Anyways, all right. Remember, chords are any lines within the circle that have two endpoints on the circle. Okay, let me increase my thickness. I don't know why my lines are super thin. Okay. And so my intersection is again going to be P, and yeah, there's P, that intersection between the lines. Okay, so let's say this is A, B, and this is C. Actually, I'll do C here. Actually, no, I don't think it matters. A, B, and C, D. Okay. Um, so now power of a point will say that PA times PB is equal to PC times PD. Okay. So as you can see, like this formula and this formula are literally the exact same thing. Okay, these things are equal. And I think that's part of the beauty of PowerPoint. No matter like where your intersection between the two lines are, your formula is essentially the same. It's always PA times PB is equal to PC times PD. You just have to know like what is your A, B, C, and D, right? But those are the intersections of the lines with the circles. So if you can identify like A, B, C, and D, like no matter what you do, like your PowerPoint will always work, regardless of whether the powerful point is outside or inside the circle. Okay. Cool. Is that idea clear? Like, does this make sense? I think it's very like it's very cool that like, oh my gosh, what did I do? Yes, Ashit, go ahead. Ask your question while I fix whatever I did. But anyways, while Ashit is typing that, I feel like it's very interesting that you can get the exact same relationship with both cases. Like I think that's so cool. Okay, there we go. So these are our cases. I'll make this a little smaller. I'll leave this up for the first couple questions, so you guys can kind of like reference it, and then I'll kind of like phase it out. Okay. Um, okay, so Oshrid asks, will this theorem only work when A and B is opposite and C and D is opposite. Okay, so when I defined A, B, and C, D, those are the intersections with the line. So A, B are the endpoints of one chord or secant, and C, D are the intersections of another chord or secant. So all this is saying is like you basically have like your point P, and you take like one segment from P to the first intersection with the circle, multiply it by the other intersection from P to the second intersection with the circle, and that's going to equal the same thing with the other chord. So if you see here, like it doesn't matter what A, B, C, and D are, okay? All that matters is like I just have this line like line L intersects the circle at two different points. And what I care about is taking that first distance, the short one outside the circle, and then multiplying it with the total distance. Okay? So PA times PC is not really a thing because you can't just multiply this and this. Now, like if you had said maybe like PC was, if you had maybe said like this was C and this was B, like that's fine. But again, like these are just A, B, C, and D are just representing like the intersections with the circles. So these are not actually like anything important. Yeah, yeah, yeah. It's just like I'm just showing you that so like you it's easy to refer to. But otherwise it's like the main relationship is this part times this part is equal to this part times this part. Like that is the essence of the relationship. And you can kind of see that here. Like actually if you drag the circle and you just redraw like A, B, C, and D, like it's the exact same thing. So that's kind of like where that comes from. Okay. Cool, cool, cool. Malin asks, what about PA. Okay, so remember L is just describing this line. It's not a point on the line. So BL, first of all, is not even a thing. But even if I said like that existed, you can't measure the rest of this line, right? A line is infinite. It has no endpoint. So if I just go from B like onwards, there's no measurement for that because it's just infinity. Okay? So that doesn't technically work. Hitarth says, I understand now. Last class I didn't understand. No problem. I'm glad you get it. Okay, awesome, awesome, cool, cool, cool. All right, good. I'm glad we got all those clarifications done. So let's talk a little bit about like why this is power. Okay, hmm. Okay, cool, cool, cool. So let's look at some. Do I want to do? Wait, okay, actually, wait. I feel like maybe we can do proofs because you guys are like kind of understanding this. Do you guys want to do like a proof of the theorem, or do you guys want to like just jump straight into a problem? Okay, wait, I saw yes, but I don't know what yes is for. Okay, jump a problem. Okay, so we'll do some problems. Maybe if we have time at the end of class, we'll do a proof. Okay. Um, okay, let's just start with a quick practice problem and then I'll talk about this. All right, so here is our first question. Two chords A, B, and CD intersect at point P inside a circle. If AP is equal to 3, PB is equal to 4, and CP is equal to 2, find PD. And like Oshrid says, I would definitely draw this out. So if you don't already have pencil, paper, and something else, um, go get that so you can solve the problem. And Audie, yes, we will definitely do a practice problem that uses something like case 2. Okay, I see an answer from Manit and Sai and Hall and Hitharth. Let's see if anyone else agrees or disagrees. I think Audios, what is case 3? I think you're referring to like case 2, which is inside the circle. Yeah. So it's technically like two cases, not three. Because this middle one is like really just part of this one. It's just more specific. Okay, I see a lot of people saying 6, so let's go ahead and take a look. Maybe you did this by observation, and you just said like, oh, oh wait, actually wait, hold on. This is like inside the circle. So this is actually like that case 3 which someone was asking about. I feel like it's like too done to like change my colors. Okay, so here's my circle. This is not a great circle, but it's okay. I have two chords. This diagram is again not to scale. Wait, actually I should draw these chords in a different color. I'll use this red. Okay, so I have A and B. So this is chord A, B, okay? So my endpoints on the circle are A and B. And then I also have C and D. Okay, so I know A, oh, and then they intersect at P. So this is my powerful point, the intersection between these lines. Okay, that's my powerful point. And so oh my goodness. Okay, so in this case, I know AP is 3, I know PB is 4, and I know CP is 2. So my powerful point relationship says that AP times, oh, oopsies, times PB is equal to um, wait, I feel like maybe it's easier if I write this differently, just for you guys. So I'll say PA times PB is equal to PC times PD. Yeah, I saw Coven said that. Yeah, yeah, yeah. Okay, and we already know like half of these lengths, right? So this is 3 times 4 is equal to 2 times PD. So it's pretty easy to solve that PD is equal to 6. Okay, so that's our answer. You will rarely ever see problems that just give you all the numbers like this and ask you to find one of the lengths. More often, it'll be like this, finding this length is like a key part to solving the problem. And like you need to do power of the point to solve the problem. Okay, yeah, let's see if we can do a hard, or actually, yeah, okay, let's do one more easy one just to make sure we're all on the same page, and then we'll do a couple harder ones. Yes, yes, yes. Yeah. Okay, so let me move this up here. Oh, oopsies. That's not what I wanted to do. All right. So this is like more of an AMC 8 problem, I would say. But like it's probably still probably easier for you guys because you guys are like pros. You guys are not pros yet. Who said that? Oh, that's Coven. Yeah, you guys are well on your way though. Okay, I see a lot of people are saying 18. I don't think I'm going to draw a diagram for this one. I think it's pretty clear to see where this question is going. I have my tangent. Well, okay, first of all, my powerful point is going to be P, because that's the intersection between the tangent and the secant. Okay. You can name your powerful point whatever. It's just often called P because that's like easy to remember. But sometimes like a problem will tell you like where your powerful point is. Like sometimes you have to figure it out for yourself by drawing a diagram, okay? In this case, it's given to us, so let's just go ahead and use it. Because I'm dealing with a tangent and a secant and they intersect outside of the circle, I'm going to use my case 1a. So this thing, oh, oopsies. This formula here is what I'm going to use. And if I go ahead and apply that, I have PA, which I know is 8, times PB, oh, that's a horrible B. Oh my goodness. Is equal to PC squared. And PC, we're told, is the length of the tangent line, which is 12. So that's 12 squared. So then if you go ahead and solve for that, PB is equal to 18, and that is our answer. Okay? Is everyone good with this? All right, I think you guys are good because you all got the answer. So before we move on, I kind of just like want to recap. So you can use power of the point whenever you see like a circle problem. So you're dealing with some circles and you see some like intersecting chords, some intersecting secants, some like intersecting tangents or secants. Any of that is like a big clue to use power of a point. Okay, and then you just go ahead like write the formula PA times PB is equal to PC times PD and apply that. But yeah. Okay, so let's go ahead. We'll do like more of an AMC 10 problem. Um, and we'll see. We'll see how you guys do. Maybe it won't be difficult. I never know with you guys because sometimes you get like super hard problems correct, and it's just like, wow. Okay, no. I don't think you guys are cooked. I think maybe this will be good. Yeah. Oh, whoops, my bad. I didn't mean to zoom in that much. That was totally my bad. I apologize. Okay, I see a lot of people putting 7.5. Oh, Manise is easier than the last one. Okay, wow. All right. Let's go ahead and take a look. All right, so now we're dealing with chords, which remember chords are inside the circle. Um, Wait, sorry, I was like stressing. Okay, I was like, what color am I gonna use? Sorry. Okay, cool. So we'll use red. So we're dealing with two chords that intersect inside a circle at point P. So one chord is divided by P into lengths of segment 5 and 12. So that's probably gonna be like one side of my equation. So 5 times 12. And that's going to be equal to the lengths of the other chord. So the other chord is divided by P into segments of length 8 and x. So we want to find x. So we have 8 and x. So they actually gave x to us. And so if we go ahead and solve this, like it's pretty easy to see that x is just 60 over 8, which happens to be 15 over 4, which is 7.5, like many of you guys said. So yeah, I would say this is absolutely a correct answer. Okay, good work. Yeah, I think that was actually easier than the previous question. Okay, cool. Um, okay, yeah, let's do another one. I don't know, maybe this one will be harder. I don't know. We'll see. Oh yeah, and shout out to Melvin for getting the answer correct. Thank you, Coven, for pointing that out. Appreciate that. That's very nice of you. Okay, maybe this is like math counts. I would say this is more like math counts chapter than state. Um, we'll see. Oh, I don't see any answers yet. Okay, wow. Oh wait, as soon as I said that, you guys put in answers. Okay, that's cool. That's cool though. All right, so I see a lot of people saying five. I see more than saying 10. Okay, awesome. Okay, I see lots of fives. Mother says, I'm not sure. Ashra says it can't be five. Okay, interesting. All right, I'm gonna give you guys a couple more seconds, like maybe to check your work, maybe to like see if you are actually right. But yeah. Okay, I see more problems, which is good. Or sorry, more answers. Sorry. That's what I meant to say. Okay, I'm still seeing like a good split between 5 and 10. So let's go ahead and like see what the correct answer is. For this one, I think I will draw a diagram just because there's quite a bit of disagreement on what the answer is. So I'll use this nice teal color. Okay, that is a horrible circle, so I will redraw it. It's okay. That's a lumpy rock or a potato. Okay, so we have circle O, and remember if we have like a circle something, that next letter will be the center. So circle O, where O is my center, has radius 5. So this is my radius, and this is 5. Okay. And I have point P that is 13 units from the center. All right, so let's draw that in purple. So at 13 units from the center, maybe somewhere like here. And so say this is point P, okay? A line through P intersects the circle at points A and B such that PA is equal to 8. Um, find AB. Okay, awesome. Oh, this is actually a very interesting question. Hmm, let's see. How do I want to draw this diagram? A line through P intersects the circle at points. Okay. Oh, okay. I know how I want to do this. All right. So maybe I'm gonna do like maybe something more perpendicular, like this. Okay. And this is 5, and we know this is 13. Okay. Awesome. And we'll say a line through. Okay. So something like this, maybe, right? Um, we'll say this is A, and this is B. Okay. So the power of P. P is our powerful point. All right, cool. So I drew this kind of threw you off. We actually don't care about this at all. So I'm gonna delete that. More importantly, we care that our radius actually goes all the way to the end of the circle, right? So we'll say like this is our radius. We know this is 5, and we know P is 13 away from the center. So this, and maybe I'll call this like X or something, okay? This entire length and let me maybe get this in green. Oh, oopsies. Okay, actually, I also realize this 13 is poorly placed, but I'll come back to that. Okay, so this entire thing is going to be 18 long. Okay, 18 units long. Um, cool. Yeah, I'll put this here. So what we're trying to say is PA times PB is equal to, and let's say maybe this point is y, PY times PX. Okay, so this is definitely a more tricky problem because you have to be really careful about what the lengths are, right? So if we know that P, like the length from P to O is 13, and we know the radius is 5, then we know that PY is 13 minus 5. So it's length 8. Okay. We also happen to know what PA is, and we need to find what AB is. So we need to find what this thingy is. So let's go ahead and start substituting, right? We have PA is 8. We know what PB is, or we don't know what PB is, so I'm just going to leave that as PB. Um, we know what PY is. We found that it's 8. And do we know what PX is? Yes, we do, right? And that's kind of why I had to draw the radius here, because we have from P to O, and we need to extend this line to actually intersect the circle. That's how we can use power of a point. So if I go ahead and intersect this, like thingy, I'll get 18. And so PB will actually be equal to 18. But that's not what we want to find. We want to find AB. So AB is going to be the entire thing minus 18. So PB minus PA, which is equal to 10. Okay, and that is our final answer. Okay, that also took me a couple seconds to like think about how to do it, which is why I always encourage um, encourage you guys to like read the problem carefully because like it's very easy to mess power of the point up if you're not careful with your like line segments and things. So yeah, definitely like don't rush the problem because it's an easy thing to apply, but like if you use the wrong lengths, yeah, that's like not good. But yeah, good job, Madden, for like getting a correct answer, even though you got something different from everyone else initially. I know that can be weird sometimes. Okay, Amika asks, why do we extend it? Okay, good question. So the reason why we have to extend it is we can only use power of a point if the two like lines intersect the circle. So in case one, like you can see this line L and M intersect the circle. Here the lines intersect the circle, and here the lines also intersect the circle. Even though they're inside the circle, they have endpoints on the circle's edge, right? That's because power of the point requires us to intersect the circle and then have the two lines also intersect each other at one point. Okay, so that's just like the way power of the point works. In this case, we know the length from P to O, but O is the center, right? So this segment that I drew in purple only intersects the circle at one point. So to intersect the circle again, I have to extend the line throughout the radius and intersect at X. Okay, and so once it intersects at the second point, then I can use the lengths that I know to apply power of a point. And honestly, this is like a good rule of thumb. If you're ever given a point that kind of just stops in the middle of the circle, always extend it to intersect the actual circle, okay? Because that line is going to be much more valuable than like a segment that stops in the middle of the circle, okay? That's just like a good rule of thumb to solving any geometry problem, whether it's power of a point or not, okay? Cool. I hope that was helpful. Was this like a little harder, or is this still like super easy? I hope it was harder. Um, but yeah. Okay, Asher says this finally makes sense. Okay, that's good. That's really good. It was hard. Okay, I'm glad. I'm glad you guys got a hard problem. Oh, Monique did not get this problem. Okay, let's go ahead and do a quick recap. And then yeah, we'll do some more good questions. All right, so starting off what we did here, and maybe it was a little confusing because I was like also low-key figuring out how to solve this at the beginning. What we did was, okay, first essential step, drawing the diagram. Oh, Minnie didn't get what I was asking until I explained it. Okay, great, great, great. Then I won't re-explain. Okay, because I think everyone got it. Okay, awesome. No worries though. If you guys do have a question, like, do let me know. Okay, so I'm gonna move this here. All right, let's do another problem. Hmm. Okay. This may not be super difficult, but I think it'll be like a good algebra exercise at the very least. So let's go ahead and do this. Boop. All right. Oh, whoopsies. Okay. Actually, like it might not even be algebra. Like maybe you guys could just like do it super fast. I don't even know. We'll see. Okay, no worries, Tharth. Thank you so much for joining. Yeah, yeah, yeah. Appreciate you. Have a great Thanksgiving. Well, then asked, is this a decimal? Yeah, I would say there's a good chance it is. Oh, actually, hold on. Let me even make sure these solutions are real. Wait. Um, okay. On second thought, actually, no, no, no. It should be okay. Wait, yeah, yeah, no, it should be okay. Okay, cool. Um, yeah. Okay, I see answers. I do see answers. Cool, cool, cool. Okay, yeah, this is also okay. Yeah, yeah, this is probably less geometry than algebra. But let's go ahead and take a look. Okay, so I see 15, and then I also see decimal answer of 4.85. I don't know what the correct answer is, so let's go ahead and solve it together to figure out what the correct answer is. Starting off, I don't think I've used. This dark violet. Okay. Um, so two chords intersect inside a circle, dividing one chord into segments of 6 and 8. So if I have 6 times 8, because those are the two lengths of one chord, that's gonna equal, let's see, the other is divided into segments of length x and x plus 5. Okay, is everyone clear like where this equation comes from? I just used PowerPoint. Like I didn't simplify or do anything. Okay. For now, this is like a quadratic. So like literally the algebra stuff was one, or the geometry stuff was a one part. Now is the algebra part. So that's why I said it's probably more of an algebra exercise. So this becomes x squared plus 5x minus 48 is equal to 0. So now we need to find the solutions. Um, Looking immediately at this, I don't think I see a solution. But let me double check. Yeah, 12 4 is not one. 8 6. Okay, yeah. So I don't see a direct solution. So I think like we low-key have to go the quadratic formula route. So we're gonna say like x is equal to -5 plus or minus the square root of 25 um, minus 4 times -48 divided by 2. Okay, great. Because this is introduction to geometry and not advanced algebra, I am not going to make you guys simplify this. I see a lot of you guys putting 4.85, so thank you for doing the calculating part for me. But yeah, like that's where our answer is, okay? Cool, cool, cool. Yeah, I don't really want to simplify that. That's like not that's not a good use of our time right now. Okay, good. So this is essentially a simple problem, but like, yeah, maybe looked a little confusing. Okay, cool, cool, cool. Let's see if there is another good problem I'm gonna give you guys. Hmm. Okay, I think this is a good one. Let's do this one. And this is more, lots of words. You gotta parse through this. Okay, here is our next question. And I think now I'm gonna go ahead and like remove all of this because I feel like you guys should be comfortable enough that you don't need to rely on this. Also, that gives us more space to do problems, which is like always a positive. Okay. Oh, I just like lost half of my work. Oh no. Okay. Okay. For like the next couple of problems, like I don't have any answers, so like low key, I will also be solving this with you guys. But that's a-okay. Okay, good. I'm so glad to see confusion. Because this means like we are doing a challenging problem. I do see some answers though, so this is also interesting. All right, so I see some people saying 6. Um, let's take a look. Think I've used every color. Maybe not this ugly dark orange. I guess we'll do that color. All right, I'm gonna draw a diagram again because I think this is probably a more tricky question that I cannot do just by observation. So circle O, my center is O. I've got an external point P that is tangent to circle O at length 8. So here is my external point P over here, and it is tangent to the circle. Um, We'll say maybe it's tangent here, okay? Cool. And this is, we'll say maybe it's point X. and this is P, and this entire length is 8. You also have a secant from P that passes through the center. Okay, that's very interesting. Um, let's see, can I draw this? No, I can't. It's not letting me draw this. That totally sucks. Okay. That's my best attempt at a line without my line tool. Okay, so this circle, or this secant, passes through the center and has external segment of length 4. So this thingy, we'll say like, this is A, this is B. They're telling us this external part is length 4. Okay, so PA is 4. And they want us to find the radius of the circle. So I'm going to go ahead and say the radius is R. So my equation, based on power of a point, is going to be PX times PX is equal to PA times PB. Okay? I know PX is 8, so 8 times 8 is 64. That's going to be equal to 4. That's PA. And then PB is going to be, let's see, that's 4. This is R, and then this is also R, right? It passes through the center. That's why we know this length is R. So I'm going to say this is 4 plus 2R. Okay, stellar. So I guess, oh, this is not a quadratic. Okay, sorry. I was scared we had to do another quadratic because I low-key don't want to do that. So we go ahead and simplify this, and I don't like this ugly brown anymore, so I'm going to do some bright green instead. This is going to be 64 is equal to 16 plus 8R. Simplifying this, we can see that, let's see, is that 48? 48 is equal to 8R, so R is equal to 6, I believe. Yeah. Okay. I think I see some agreement, which is good. And if we want to go ahead and check that, you have 8 squared is equal to 4 times, if this is 6 and this is 6, the entire length is 16. So this is obviously a true statement. Yay. I just realized I've got some like tree theme going on here. Okay. Really great work, you guys. Is this starting to make more sense? Like, are you guys starting to see maybe the potential value of this? Yes, yes, yes. Okay, good. Okay, awesome. Good. Yeah. Let's see. I don't know. Yeah, I think I want to do more problems. I don't think it's worth doing the proofs for the time being. The proofs are included in the handout though, so like I would encourage you guys to look at it. Because I think it's a good insight into geometry. Geometry is like a lot of proofs improving things. So if you want to get good at geometry, like I would say learn proofs, which is something I didn't like do initially, and I think that's why I struggled with geometry. But learn the proofs, especially the ones that are like maybe in this handout, because it'll do good. Okay. Cool. Let's do another problem. Hmm. Maybe we'll do like a good challenge problem. Let's see. Okay. Okay. Here's a question from the American Regions Mathematics League. Um, I think most of you guys are in Georgia. Georgia has this competition thing. I've been on the team for the past 2 years. I would highly recommend you guys do it when you get to high school. It's a really fun competition that they do over the summer. Okay, anyways, this is a good problem. Let's go ahead and approach it. This is from the Art of Problem website, which says this is an introductory problem. I think it's a little challenging, but we'll see. Oh yes, okay, okay. So this colon means like is to or a ratio. So this signifies a ratio. Yeah, yeah, that's correct. Malden, thank you for putting that answer in. So this is a ratio. So if you have like AR is to BR, that means like the ratio of AR divided by BR is equal to 1 over 4. Okay, so that's like a way to translate that. Okay. Oh, Malden says 15 over 13. Sorry, I didn't see that initially. Um, okay, Malden, thanks for putting that answer in. Let's see if anyone else agrees or disagrees. Okay, Auschwitz says 5 is to 13. Okay, interesting. So I think we got that common ground of 13. Yeah. Okay, very cool. Okay, Bishop also says 5 over 13. Awesome. I'll wait a couple more seconds, maybe until it hits 750, and then we'll go ahead and try give it a shot. Okay, Audie also says 15 over 15 is 13. Okay, so it seems like we're split, like pretty down the middle here. So let's go ahead and take a shot at this question. I'm not going to draw this diagram because I have a perfectly good diagram given to me, and I'm going to use that. Okay, so let's see. Oh, that's so pixelated. If you guys can't see something, do let me know. Hopefully it's like clear though, what I'm drawing. Oh, I changed my yellows. Like, let's see. Hopefully this is more visible for today. All right, so I have AR is to BR. If I'm given a ratio, I'm always going to set some ratio factor. In this case, I'll say like maybe it's X. So if I have AR is to BR is equal to 1 is to 4, I'll say AR is X and BR is 4X. Okay? If I have CR is to DR, I'll say their ratio is like Y. And actually, maybe it makes more sense to do this in a different color. So I'll do this in green, or maybe not green because that's already in the diagram. I'll do like this dark blue. Um, so we have 4y and 9y. Okay. Yes, Mothman says rule number one, never trust the diagram. Yeah, these ratios are not reflected at all. Do not touch the diagram because like if you try to measure this with your ruler or something, like something will go wrong. But yeah, good job, Mothman. Okay. So we want to find like what is AB to CD. So I gotta set up like, oopsies. I gotta set up kind of like a power of a point, right? Let's do this in red. So power of a point tells me that x times 4x is equal to 4y times 9y. Okay? So I get 4x squared is equal to 36y squared. So simplifying this, I get that x squared is equal to 9y squared. And I can go ahead and take the square root. Now, the reason why I'm allowed to take the square root is because I know like x and y are both going to be positive. So like no signs or like anything crazy is happening here. So if I take the square root of both sides, I'll see that x is equal to 3y. Okay? And so if I go ahead and substitute this back in here, for my CD, I have like 13y in the denominator. And for my AB, this x is now 3y, and this 4x is now 12y. So if I go ahead and add that up, I get 15y, which simplifies to 15 over 13, and that is my final ratio. Okay, really good work, you guys, to everyone who got that answer. If you didn't, please take a look at the work on the screen. Let me know if something is confusing you, so that way we can go over it. But yeah, good work to everyone who solved this. Really great. Oh, Malvin asked me to look at this file. I don't know if the file will work because it seems like it's from your like local thingy, so I don't know if that'll open up for me, but I will try. Yeah, I don't think it'll work. That link you guys are sending, unfortunately. Okay, Asha says we did case two. Yes. Okay, cool, cool, cool. Well, let's go ahead and end with one final problem. I will do what Art of Problem Solving calls an intermediate problem. Uh, but I don't know. You guys are doing really good with some of these trickier problems though, which is great. Okay. Oh no. Gosh. No. Wait. I think this is okay. All right. Let's see. I want to make sure like this problem we can do like in the time. Okay, yeah, let's do this. This is like an old, um, oopsies, that's not what I wanted to do. This is like an old, what's it called? I think this is like an old AMC 12 problem, like super old, like from like the 1900s, like the literal 1900s. So, that might be easier than expected. Okay, so here's our problem, our final problem for this class, for today. So let's go ahead and give it a shot, and we will go ahead and end from there. I would say maybe this is like less power of a point and more circle theorems. Wow, okay, wow, this was like super fast. Okay, that probably wasn't even challenging because I already see a lot of people saying C. Let's go ahead and take a look. Okay, so here's our blown up diagram. All right, so You basically have to draw this. Honestly, drawing this is like half the battle. All right. So as I can see, like because there are two tangent lines, starting from outside the circle, like these two things are obviously equivalent. Actually, like the fact, like remember when we talked about this initially, the fact that like these two, because they're tangent and they start from the same point, they're equivalent. That can actually be shown by power of a point. So that's like really, really nice. But yeah, okay, sorry. I just thought that was super cool. A lot of those initial circle theorems we talked about can be proved by power of a point, as a fun fact. Okay, so we also know like there's a lot of equal segments here. First off, we know that AB is equal to AC, right? Because these two things are tangent. And I think we're given that AB is 20. So like AC is also 20, just super nice. We also know BP is equal to PQ. That's in our diagram. Again, it's the same tangency argument, except the exterior point is like right here. And then we also know that like QR is equal to RC. Okay, so again, you have this external point and you've got that tangency. Okay, so that's why these two are equal. And so if we want to figure out the perimeter of APQR or APR, sorry, that triangle, that's just AP plus PR times RA. Okay, so we're just going like this. Easy peasy to find that parameter. Um, we kind of already know that PR from this diagram, just from this diagram, I'm not doing anything crazy, can be shown as PQ plus QR. Is that a fair statement? Like, are you guys on board with this? Like, is that something we can agree on? Yes, yes. Okay, good. I'm so glad we can agree on that. So if we go ahead and like substitute this, we can say that AP, um, that this all this is equal to AP plus PQ plus QR plus AR. Okay. And then we know that PQ is actually equal to BP, so AP plus BP. And we know QR is equal to RC. So RC and AR. But if you actually look at it, AP and BP makes up AB. And it's the same thing here. AR plus RC makes up AC. So this is actually just equal to AB plus AC. And we know what AB and AC are. They happen to be equivalent, and they're both equal to 20. So that means the final answer is 40. Okay? I would say this is less power of a point and more, I would say this is maybe more like just tangent theorems, but still a good exercise, like nonetheless. Still a good problem. Okay. Cool. I think we have time for one more. Let's see, what's a good one that I think we could do super fast? Actually, Asher doesn't get it. Okay, never mind. Let's go ahead and recap. Asher, is there a part that you got lost on? The red bit. Okay. So all my simplification. No worries, no worries. So I have AP plus PR plus RA. So my first step here is I substituted PR with this expression that I got up here. Okay. Um, and so what I did was I just went ahead and put this in here. So AP plus PQ plus QR plus AR. Okay, so that's all I did, some substitution. Now what I'm doing is I'm using the values, the equations that I found up here. I know that PQ is actually equal to BP. I also know that QR is equal to RC. The reason why I even want to change that is because we're going to find out I can actually show equivalency with this entire line AB. Okay, so that's why we're even making that substitution. And so if I have AP, that's this point over here, or this segment over here. Oh, that was like a horrible. Okay, that's the segment. And then I have BP. All of that makes up AB, right? That makes up this entire line, or this entire segment AB. And for the same reasoning, RC, this thingy, and AR, this thingy, make up the entire thing AC. And we showed because AB and AC are going to be tangent and they start from the same point, their lengths are equal. So AB and AC are equal to each other. And we also know AB is already 20. That's given in the problem to us. So 20 plus 20 is just 40. Okay, so that's all that red stuff. Does that make a little bit more sense? Okay, yay, that's awesome. So I think this is a good note to end on. So let's go ahead and end here for today. I hope you guys learned something new, especially because you joined me on your Thanksgiving break. And I do hope you enjoy like your Thanksgiving. You spend time, enjoy some hobbies. Don't just sit and watch TV all day. But yeah, all right. Thank you guys so much. Have a wonderful break. Have a wonderful day eating food, and I will see you all next week. All right. Bye, everyone. Thank you, thank you. Ashit says extend the perimeter to as much as possible. Yes, Ashit, that is correct. Yes, yes, yes. Awesome. Bye, Mari. Bye, Sachi. Bye, Audie. Happy Thanksgiving. Bye, Kevin. Enjoy your break though. Bye, Sai. Bye, Tharav. Yeah, Ashit, go ahead.
So I just want to like recap,
Yes.
kinda. So all we did is you took all of the information they gave in the question, listed it down,
Hmm.
and then saw where is it similar. Like RC is similar to QR.
Yes.
So and then you found the perimeter and you said, okay, that perimeter is AP plus AR plus PQ plus QR. And
Yeah.
then you found out that QR is RC and then PQ is PB. Can
Yes.
be AB plus AC, then
Yes.
that's how we got 20. Then wouldn't the answer be 20? Why would it be 40?
We know that AB itself is 20, but we're doing AB plus AC, right? We know AB and AC are equal to each other because they're both tangent to the circle and they start from the same point. So I'm not saying that like the answer is 20. I'm adding two things that are both 20. And because they're both 20, my final answer is going to be 20 plus 20 or 40. Does that make more sense?
Yeah, and where do you find these problems to practice from?
If you go to the Art of Problem Solving website, there's a bunch there. We'll actually go ahead and send out their link to PowerPoint, so you can check out some of the problems from there. But yeah,
Oh,
if
okay.
you search up PowerPoint, there'll be a ton of
Can
websites
you
that talk
can
about it
you
and have
include that
practice problems.
can you
Yeah, go
include
ahead.
that link in the like email that you send after class?
Sorry, say that again?
Can you include that link in the email you send after class?
Yes, that'll be in there.
Okay, bye.
All right, bye, Ashrit. Bye, Aditya. Thank you so much. Awesome. And bye, Cybernice. Enjoy your break.